Okay. The second question that we had on the circuit is if you change a series circuit with a 9-volt battery and two 10 ohm resistors or light bulbs from a series circuit to a parallel circuit, what's likely to happen? So, what I've done on the screen here is devised a way that I can make this a series circuit or I can make this a parallel circuit just by opening and closing switches. That way I don't have to redo the whole thing. So let's start off with making this a series circuit. So I'm going to start here at the battery, go down, over, I go through this light bulb, I come across, I have to close that switch, go through that light bulb and come up there. So now I have a series circuit. So let's look at the voltages. So I start with putting the black probe at the negative side of the battery. Of course, I'm going to have 0 up to here. 4.5 volts potential difference after I go through the first bulb, 9 volts after I go through the second bulb, and it's a 9-volt difference total possibly on the circuit. Okay. What happens to the voltage if I change that to a parallel circuit? Now, after I go through the first bulb, of course, it's 0 until I go through the first bulb, then it's a 9 volts. Okay. It gets to use up all of that 9 volts because if you look at the circuit, that electricity is coming through this bulb, back up through the battery. It's not going through anything else that would potentially change the voltage. Look at the other bulb. That one also gets 9 volts because that's the only thing that electricity has to go through, which might change the voltage on there. So on the series circuit, you use up 4.5 volts on the first bulb. You use up 4.5 volts on the second bulb. On the parallel circuit, all 9 volts are available for both of the bulbs. Since you're going through 2 bulbs, you get the 9 volts both times. Now, let's change this again back to a series circuit. Let's look at the current. 0.45 amps. Put it here, 0.45 amps. We know that on a series circuit, no matter where I go, it's going to be the same amperage. Why? Because all of those electrons are following the same path and they can't pass each other. And they all have to go through all of those points. They just keep flowing. Whatever the slowest electron is, that's what they all have to abide by. Let's open this, close that, close that. Now let's see what the current says. Over here, I've got 1.80 amps. So my total amperage is 1.80 amps all the way up to when I go through this part of the circuit. So half of the amps, 0.9 amps, goes through this light bulb. So it's got all of the voltage, but only half of the amps go through here. Then I have another 0.9 amps that go through this light bulb. And that 0.9 amps joins back up with this 0.9 amps and gets me back to 1.8. So that's basically how that point works right there. The other question is, if I have a parallel circuit with a 9-volt battery and a 10 ohm resistor on each of the loops of the circuit, what happens when I use a switch to turn off one of the loops? So right here I have a parallel circuit. I'm going to turn one of them off. Let me put my voltage up here first. So I know right now I've got 9 volts everywhere, right? So let's turn this off. Voltage stays the same, doesn't change. This is 0. This is 9. Actually, I have a potential of 9 volts here because I just don't have the switch closed. But let's look at the amperage. If I close this, I've got 1.8 amps up to here. I'm putting 0.9 amps through here, 0.9 amps through here. Let's open that circuit. Now, instead of having 1.8 amps and shoving 1.8 amps through here, now I actually have only 0.9 amps because that's all that I'm putting through here. Okay. That 0.9 amps would go to 1.8 if I was using another 1.8 over here. Okay. So it's kind of backwards. It's not dependent so much on the source there. It depends on the potential difference and what you're using there. So keep that in mind as you're going through this. That's the difference.